Have you ever pondered over the fact that the universe is expanding? But what does that mean exactly? Well, imagine a balloon. As you blow air into it, the balloon inflates, and every point on its surface moves away from every other point. The universe, in a similar way, is expanding. This idea sprouted from the Big Bang theory, which posits that our universe began as a tiny, hot, and dense point about 13.8 billion years ago. Since that fiery birth, it's been expanding, with galaxies moving away from each other. Now let's talk about the cosmic microwave background radiation. This radiation is like the afterglow of the universe's birth. It's the oldest light we can see, a remnant from the time just after the Big Bang. This radiation fills the universe and can be detected everywhere we look. So when we say the universe is expanding, we mean that the space between galaxies is increasing, just like the surface of an inflating balloon. We often hear about dark matter, but do you know what it is and why it's so important to our understanding of the universe? Dark matter is a type of matter that, despite making up about 85% of the universe, remains largely invisible. It's like a ghost, unseen because it doesn't interact with light or any other part of the electromagnetic spectrum. But don't be fooled by its elusive nature. Dark matter plays an essential role in the grand architecture of the cosmos. It's like the invisible shelves of a bookcase, holding the books, or in our case, galaxies, together. Without dark matter, these galaxies would simply drift apart, leaving the universe a vast, empty void. So how do we know it's there if we can't see it? We observe its gravitational effects on the visible matter around it, like stars and galaxies. While we can't see dark matter, we know it's there because of the gravitational effects it has on what we can see. Black holes are a fascinating mystery of the universe, but what are they really? Imagine the most massive stars in the cosmos. Over their lifetime, these stars burn through their nuclear fuel until they eventually implode, leaving behind a dense core. This core, under the weight of its own gravity, collapses in on itself, forming a black hole. Now black holes are like cosmic whirlpools. Their gravity so intense that nothing, not even light, can escape their pull. Picture throwing a pebble into a whirlpool. Just as the pebble gets sucked in, so does everything that comes too close to a black hole. At the heart of a black hole is the event horizon, a point of no return. This is where the gravitational pull becomes so strong that it warps space and time, drawing in all matter and light that strays too close. Black holes are the universe's ultimate enigma, a region of space where the rules as we know them cease to apply. Now, let's delve into the mysterious concept of dark energy. What is it and why does it matter? Picture driving a car on a highway. You're cruising along and suddenly the car starts to speed up, all on its own. This is akin to what's happening in our universe with dark energy. Dark energy is a hypothetical form of energy that permeates all of space, causing the universe to accelerate in its expansion. It's like an unseen force, pushing the galaxies away from each other at an increasing rate. It's mind-boggling, isn't it? Understanding dark energy could help us unlock the secrets of the universe and its ultimate fate. Will it keep expanding forever, or will it eventually collapse back on itself? As of now, we don't have all the answers. So, dark energy, while still a mystery, plays a crucial role in our understanding of the universe and its ultimate fate. Our cosmic journey continues as we strive to decipher this enigma.